Hi, my name is Mandy and our group is Group 03 Visionary, and I would like to introduce my group members. So there are Devon, Caroline, Teresa, and Debbie. So our group topic is renewable energy consumption and electricity prices in the United States from 2001 to 2021. This study is related to the Sustainable Development Goal 7, which focuses on providing affordable and clean energy for everyone. Electricity is something we use every day, whether at home, in schools, or at work. So making sure it is both affordable and sustainable is very important. For the research problem, over the past few years, the United States has been using more renewable energy, such as solar and wind energy. This change is mainly driven by the environmental concerns, climate change, and the need to reduce the dependence on fossil fuels. However, electricity is a basic necessity for the households and industries. When renewable energy usage increases, some people worry that the electricity prices might also increase. Higher electricity prices can affect people living costs and business operations. Because of this, our study focuses on understanding whether the increase in renewable energy consumption in the US is related to changes in electricity prices. For the research objective, based on the issue, our study has four main objectives. Firstly is to examine the trend of renewable energy consumption in the US from 2001 to 2021. Secondly, to analyze the trend of average retail electricity prices in the US during the same period. Third, to determine whether there is a relationship between renewable energy consumption and electricity prices using the statistical analysis. Finally, to relate our findings to the SDG 7, which emphasize affordable and clean energy. So overall, these objectives help us to better understand the impact of the renewable energy on electricity prices.
For this slide, I will explain the dataset used in this study. The study used a quantitative and time series data which allow us to observe change and pattern over time in a systematic and consistent manner. The dataset focused on the United States that covered the period from 2001 to 2021. This 20-year period is particularly important because it enables to analysis of a long-term term in the energy sector, especially in relation to renewable energy development and electricity pricing. Next, I will explain the key variables included in the dataset. The first variable is renewable energy consumption, which is measured as a percentage of total final energy consumption. This variable shows the contribution of renewable energy sources such as solar, wind, hydropower, geothermal, and biomass to the overall energy mix in the United States. By using this measure, we are able to understand how the role of renewable energy has evolved over time. The second variable is electricity price, measured in cents per kilowatt hour. Especially, this represents the average residential electricity cost faced the consumer. This variable is important because it reflects electricity affordable and allow use to examine change in electricity price throughout the study period. Having explained this data set, I will now move on to the data sources. The data on renewable energy consumption will obtained from the World Bank World Development Indicator, which is a widely recognized and trusted international database. Meanwhile, data on electricity price were sources from the U.S. Energy Information Administration, an official agency that provides comprehensive energy statistics for the United States. Finally, these sources were selected because they are official, renewable, and consistent. This ensures that the data are suitable for statistic analysis and trend analysis, and that the findings of this study are credible and meaningful. In conclusion, the dataset and sources used in this study provide a strong foundation for analyzing trend in renewable energy consumption and electricity price, as well as examining the relationship over time. Thank you.
Next, I'm going to present the data presentation. First, we categorize the 21-year period into 3 development phases based on renewable energy consumption. As shown, 48% of year 10 out of 21 fell into the median phase. Only 3 years, or 14%, reached the high phase, or in the recent period of 2019 until 2021. This indicates a clear but gradual progression. From an SDG 7 perspective, this shows measurable progress, but also highlights that maintaining level above 10% consistently requires continued effort. Now let's look at the quantitative analysis. The histogram on the top shows renewable energy consumption is right school. Most years cluster at lower levels, but there is a tail extending upward, indicating growth potential. The trend chart at the bottom reveals our most important finding: 3 distinct phases. Particularly from 2010 to 2019, we observed a decoupling phenomenon. Renewable energy grew by 3 percentage points, while electricity prices remained remarkably stable. This challenges the common assumption that renewable energy necessarily drives up prices. Statistically, renewable energy grew 132% over 21 years, while prices rose only 72%, demonstrating that clean energy transition can coexist with relative price stability. That's all from me, and I will pass to the next person.
For this slide, the slide presents the measure of central tendency for electricity prices and renewable energy percentages. The mean electricity price is 9.73 cents per kilowatt hour and the median is 9.9 cents, showing the prices are fairly balanced. The closeness of this value suggests a symmetrical distribution with no extreme price influencing the average. For renewable energy, the mean is 7.86%, while the median is slightly higher at 8.4%. This indicates a slight skew toward the lower value, with some lower observation pull the mean down. The mode is not applicable for both variables, meaning no single value occurs most frequently. Overall, the results show a stable electricity price and moderate variation in renewable energy share across the dataset. This slide summarizes the distribution of electricity prices and renewable energy percentages. For electricity price, the value range from 7.2 to 12.36 cents per kilowatt hour, giving a moderate range of 5.16. The low variance and standard deviation indicate that the price do not fluctuate significantly, and the coefficient of variation of 0.127 confirm that electricity prices are relatively stable over time. In contrast, the renewable energy percentages range from 4.7% to 11% with a wider range of 6.3. The higher variance and standard deviation show greater fluctuation, and the coefficient of variation of 0.249, almost double that of electricity prices, highlight much higher relative variability. Overall, the renewable energy usage is more volatile, while electricity prices remain comparatively consistent and stable. On this slide, we're going to examine the distribution of electricity prices and renewable energy share using the quartile and the 90 percentile. Starting with electricity prices, the first quartile is 9.13 cents per kilowatt hour, meaning 25% of the prices fall at or below this level. The median is 9.9 cents, while the quartile increased to 10.48 cents. The 90% is 10.59 cents, showing that only a small proportion of prices are relatively high. For renewable energy, the first quartile is 6.3% with a median of 8.4%. At the third quartile, renewable energy rise to 9.3%, and the 90 percentile reached 10.2%, indicating that very high renewable share are less common. Overall, both variables show a gradual and steady increase across quartile. The small gap between the third quartile and the 90% suggests moderate variability and a consistent distribution with no extreme earlier. Thank you. Interpretation in the context of chosen SDG, which is Sustainable Development Goal 7, which focuses on affordable, reliable, and sustainable energy. The results show that electricity prices in the United States are stable with close mid and median value and low variation. This indicates that the electricity remains affordable and predictable, supporting the SDG 7 affordability target. However, renewable energy adoption show greater variability, meaning the progress toward the sustainability is uneven. While some places perform well, high renewable energy share are not yet widespread. Overall, the US is strong in maintaining affordable electricity, but it requires further investment and policy support needed to expand the renewable energy consistent and fully achieve the SDG 7. That's all from me.
Okay, thank you. My name is Devon, 9862. Okay, moving into our result. Our statistical analysis confirmed that very strong positive relationship between renewable energy consumption and electrical prices. We recorded a Pearson correlation of 0.9271 and Spearman rank of 0.9857. To put it simply, the US increased its reliance on renewable energy from 2001 to 2021, and the electricity price rose because of that. With a p-value of 1.11 and 1.55 times 10 negative 9, we can say that in high confidence that this trend is statistically significant and not due to random changes. Okay. 1.0. Now, what does this actually mean for the country? The rise of prices is largely due to upfront capital, like cost to build a new transmission lines and battery storage is expensive. This creates a paradox for Sustainable Development Goal 7, SDG 7. While we are achieving clean energy, we face a challenge with affordability energy in short term. However, in long term, outlook is positive as technology matures and we move away from volatile fossil fuel market. We expect to see greater price stability and significant progress in climate action and more job creation. Okay. For conclusion, while there is a clean upward pressure on electricity prices during this transition period, it is a necessary investment. The data show the shift towards renewable energy is well underway. By addressing the infrastructure cost now, the US is laying the groundwork for more stable, sustainable, and carbon neutral future energy. Thank you.